Yeah, so like we've been in like Zach was saying, we've been in the industry like in high performance for like over 10 years now and building Passive House since then. The one thing that's I guess we have to update. We have a living building under our belt now too. It's small, but it is fully certified, and we're really proud of it. So we really try to show what's possible and what can be done on any scale, and that's this is really a project that showcases that as well.
Yeah. I suppose it's also worth mentioning that we're among the 27 firms in the nation currently that are meeting that 2030 challenge, that we can go into in more depth later if people are interested in hearing more about that. But basically, we're on track to have all of our projects be carbon neutral by 2030, which means that right now we're reducing their operational energy emissions by 80% across the board. So let's jump in. Let's focus on the case study at hand today, which is the New Day School. This is a preschool in Southeast Portland, Oregon, along a bike boulevard. You'll see that there's a couple buildings here that are labeled as phase 1 and phase 2. Today, we're really going to focus on the phase 2 building that we did a deep green retrofit to. And then the phase 1 building that has the white roof with the skylights was a basic energy, lighting, and acoustic retrofit that we did beforehand. Built in 1960, that phase 2 building, no insulation in the walls or the roof, single pane windows, or a really old gas furnace that was not keeping it warm enough for the kiddos during the winter. And that non-insulative envelope was causing a lot of heat, unwanted heat gain in the summers. That was pretty unpleasant. In fact, they would have to close during the really hot days that are happening more and more out here on in the Northwest now. So in the end, what we were able to transform that building on the left with the solar panels into is essentially a net carbon or a net positive energy building, and making the campus actually like a zero energy campus when we all things are said and done. And so we'll dive into the specifics of this. But Alex, did you want to chime in on anything here?
I mean, so we're what's really important, I think, the key piece here is two. One is it's a school, and we're going to talk about the benefits for schools, particular of high performance and associated ventilation and indoor air quality. And the other one is retrofits. We're also talking about why it's important, but we have so many buildings, existing buildings, and I think we have the topic of embodied carbon, and this is one way to reduce carbon, embodied carbon when we retrofit buildings, which we have to do because we have so many anyways. So this is really what we want to focus on, is so that's possible and what's possible to do with an existing building.
Mm-hmm. Want to just touch on what really inspired the client to embark on such a big and challenging project. We haven't yet met another or heard of another preschool in the nation that has achieved this zero energy benchmark. If you guys know of any other preschools that have, let me know, because then we'll stop saying that we're the only one. But they were really inspired to do so for a couple of reasons. One of which is that one of the directors built their own passive house, designed and built it. And so they brought that to the table and got everybody on the directorship and staff level excited about kind of doing a project that used passive house principles. Was kind of where we landed, right? It's not certified passive house. They also have subscribe to a philosophy called the neo-humanist philosophy, which basically means that they extend the love that they have for humans to all beings, which dovetails very nicely with our thinking around sustainability and regenerative design, because they don't want to use or take more than they need to, and they really want to give back. So they were all for as sustainable of a building as possible. And then they also really saw the need to upgrade their building, especially for seismic reasons. They are part of neighborhood groups around resiliency, specifically in regards to the big earthquake that may happen in our lifetimes on the West Coast. And many of our buildings, including this one prior to the renovation, was not ready for a big earthquake. So that's what helped them come to us to make this project happen.
And so the goals that they really brought to us, again, safe and secure was important to them. Sustainable and resilient is what they're really kind of the last bullet point here says is the beacon of hope. Like they wanted to be this a special building that really kind of embodies the what they call here serenity and uplifting. So they really wanted to make this an educational space, particularly for the little ones, that is healthy and that protects them and that's still inviting. So it's secure and inviting. You see all the light, but everything is open and transparent. And that's the goal that the goals that they came with us to us. And so I think the next slide we want to talk about how we transform that those buildings.
Yeah. So as you all well know, figuring out how to conserve energy passively is what we first do, right? Before we figure out what kind of system we need to install to power it in a clean way on site. And so one of the ways we obviously did this was to really maximize that balanced daylight. The classrooms before we did our retrofit were single aspect. They only had glazing on one side of the classroom. So it was causing glare and poor daylighting. So they were having their lights on all the time. So we removed many of the interior walls except for the center of the structure, kept all the exterior walls, which we'll talk about later when we talk about embodied carbon, so that the classrooms could really have 2 and 3 sides of light, ample daylighting. And then the LED lighting that we installed adjusts to daylight levels. So the teacher doesn't have to remember to switch off the lights when they don't need the lights do that themselves. And then there are overhangs and interstitial spaces that really buffer the spaces from excessive heat gain and glare during the summer times. In conjunction with that, we obviously optimized the envelope insulation. So I don't think I mentioned, but the structure actually had kind of 4x4 post construction, and we kept those exterior walls. We didn't want to take down that structure and add our typical 2x8 construction because that would have a huge embodied carbon impact, right? So we kept the existing outside walls, filled in the cavity with recycled dense packed cellulose insulation, and then added that extra insulation on the outside. In this instance, it was 1.5 inches of wood fiber, specifically Gutex we really like to use. And again, that's a nice low embodied carbon material. So that got us at like an R26 and some change in the walls. And then we couple that with triple pane windows. We really love to use Zola. It's the best bang for the buck that we've found. We've tried many triple pane glazed windows and doors before, and we always end up back with Zola. They're a pleasure to work with and fun to install. And then the roof, similar to the walls, we filled in the existing cavity. We kept the framework of the roof framing. So got to an R80 by filling in the cavity with dense packed recycled cellulose, and then added 8 inches of EPS foam on top of that sheathing because we lose more heat from the roof than the walls. So we're really focusing the majority of our insulation on the roof. We did not take out the foundation so that we could insulate the foundation. Again, for carbon reasons, we kept the foundation as is. So working with the Lego pieces that we have. What we did do though is insulate the edge of that foundation, right? So the exposed 4, 5, 6 inches that we had, we made sure that that was insulated. What else we got?
Right, so the challenge in a retrofit, as many can imagine, is airtightness, right? So we opted, because we had existing structure, we opted to do an interior air barrier, and obviously the installation by the book is what we were able to do on the ceiling, which you see in the middle here, where you have a service cavity. You can see some wiring run, so like you really minimize penetrations, and areas for leakage. In the walls, we opted to not do a service cavity, and we had because we had very limited penetrations at that point. However, you can see, like, we did a smoke test that was, of course, the areas that were hardest to seal. In the end, we did get to one ACH 50, and we kind of had to share here our blower test results before and after. Like in the beginning, before the retrofit, we couldn't even pressurize the building. So we maxed out the door at 25 Pascal and roughly 6,000 CFM. And then at 50 Pascal in the end, we had like 626 CFM. So it's a success for us. And the only takeaway here is, service cavity is really the way to go for an interior air barrier. And then, like those are our envelope measures. And really what we really were interested in is to apply, like what kind of systems we could apply here. As we know, when we reduce the loads, we can now focus really primarily on ventilation, and that's what you see here in the upper left corner. is Ventacity HRV. So it's a commercial sized HRV that provides efficiencies that we're used to from like Zender and other, high performance HRVs. They're actually local to us, right, in Portland. And so we were able to use commercial sized HRV to provide ventilation for the entire building. It depends on who you're talking to for ratings. I think Passivhaus Institute says around in the lower 80s. HVI says like in the 90s in terms of efficiency. And you see in the center picture, a ducting that distributes that to the rooms. It's controlled by CO2, right? So the challenge is, particularly in schools, we have like a ton of occupancy if all the kids are in the classroom, and then very low occupancy, like if there's recess or after hours, and there still might be people in the building, administrative staff. And so CO2 is really how we control the airflow to maximize efficiency by still providing enough air, during the day. And then what's left is, as you can see again here in the middle, it's really residential sized heat pumps that heat the classroom. And they've been comfortable. Like you might have heard, like Pacific Northwest is a moderate climate, but we had, like incredible smoke events. We had an ice storm. People were out of power for 2 weeks, and the famous heat dome, 115 degrees, and they cruised right through all of those. So it's really a success in terms of comfort. We were talking earlier about the building being all electric, so it's also heat pump water heater. So it's an all electric building focusing on ventilation.
For you? Yeah, good.
So Alex will share some more specifics, even graphs in a moment, to really illustrate how much energy we were able to reduce, like the energy loads that we were able to reduce. But in general, we after all of our conservation measures, we only needed half the solar panels than we would have needed otherwise. And so it made the system much more easy to afford actually putting the solar panels up on the roof. The client decided actually though to max out the whole roof that you can see, so that the building itself is net positive energy. And then its extra energy that it produces goes back to the grid, gets credit for it at the same rate that they pay for the energy, and basically balances the books with the energy needs of the building to the right. So in essence, you could call the campus a zero energy campus. They have batteries on site, which allows the building to draw from the batteries when the PV is not able to generate power, which really helps, as you can imagine. And the big deal for the clients, obviously, is that they don't have an energy bill when everything is summed out. So better teacher salaries, more supplies, more resources for those kiddos.
Right, and so here's some graphs, like raw light graphs. I have to admit that this is still model data as opposed to actual, which we're still analyzing. But essentially, we were able to reduce the EUI by 50%, right? So from 25.7 to 12.9. But what the kicker is for us still is the peak demand, right? What we're talking about, because we're talking about zero energy, and saying like that's a big important message for us. All Greenhammer's buildings, all new construction buildings are currently zero energy. But we really want to explain to people that it's not just about PV, it's about efficiency first. And this matters, right, for the winter gap, right? If we able to produce a lot of energy in the summer, that's great. But if you have to pull it out of the grid in winter, then we're not really taking advantage of the carbon emission reductions that we could, because even in the Pacific Northwest, where we have hydro, in peak demands, we're still firing up coal plants. So what's critical for us is to really reduce the peak demand in winter. And we were able to do that, right? So that was really a success for us. You can see like 80% in winter and 66% in summer. That's our reduction in the peak load. So we're really happy about those results. So again, the focus is on indoor air quality, the environment for the kids. And again, we've got 100% outside air that we're providing here. Which is, again, in the commercial setting, we're a small company. We do single family, small multifamily, some commercial. But as most people know who work in commercial, it's like providing 100% outside air is not very common yet, and it really has a huge impact. particular on cognitive abilities. There's this famous study with Harvard. So here, really, the kids have the ability to take advantage of the 100% outside air, light, and materials. Laura, do you want to talk about the materials?
Yeah, sure. So if our indoor materials are off-gassing to any measurable degree, then it's just an uphill battle, right? So we really focus on making sure that the materials that we put into these spaces, especially when we're talking about a preschool with little lungs, developing lungs, we're focusing on natural non-toxic building materials. Wood, of course, wool carpets, linoleum floors. That main ingredient of linoleum floors, I mean, it's got like 3 ingredients in it really, but it's flax seeds, it's off-gassing, omega-3 fatty acids. If it was in any measurable quantity, it would actually be good for your health, but it's such a small amount that it's just negligible. We've already talked about natural light and views. We know that it's good for our bodies, our brains, our spirits to be connected to circadian rhythms, experiencing seasonal changes and weather and nature patterns, but that's especially true for kiddos. So we really focused on that in the renovation of this building. And then you'll see scattered throughout these images that you're seeing like some biophilic design elements. I think designers oftentimes intuitively lean on biophilic design, but we really tried to be a little bit more intentional about it here, getting curvilinear elements in, earth tones, plants indoors. That's just the kind of space that the school and its philosophy really values. So we worked with the client on developing those ideas. We have touched on embodied energy a bit throughout this whole presentation, and I know it's becoming more and more a center point of conversations as we're talking about carbon in general and how we can reduce it. So yeah, the main thing that we did is we reused as much of the structure as possible. We didn't start from scratch. That's like number one. And then the materials that we did add to the project, we were really conscientious about choosing ones that were low embodied carbon, right? We talked about the Gutex. We're really focusing on wood. We didn't take out the concrete. And then when we did deconstruct what we did, we worked with a wonderful company here in Portland, Oregon, that really deconstructs things very carefully so that everything could be reused. Everything that could be reused was reused. And then the insulation, right? Doing the dense pack recycled cellulose insulation has a really low embodied carbon impact. And we can go into more about this if people are interested to talk about this. We can. Yeah. Were you going to say something, Alex?
I just have to point out FSC, right? Forest Stewardship Council certified lumber. It's such a big one. We all talk about the benefits of wood and bio-based materials. And it's important that really the wood is grown and harvested sustainably. So we're, again, like Pacific Northwest, we're kind of the woods area of the country. And for us, it's particularly important because we walk in it, every day. But FSC certified wood really makes a big difference in terms of carbon in embodied carbon and carbon emissions, because if clear cuts, the forest floor combines so much carbon or binds so much carbon in the forest floor that all gets released. If it's clear cut, which is doesn't show up in any kind of like building accounting system for embodied carbon. It's a different calculation. And so it might not show up, and what looks great on paper, but if it's not FSC certified, it's not as good as it could be.
Yeah, I'm glad you mentioned that, Alex. We just have a couple more slides, and then we really want to open it up to questions and discussion. The client was well aware and interested in addressing some, but not all aspects of resiliency. They knew they wanted to be ready for the earthquake, right? So they did this seismic retrofit. We talked about that being one of the impetuses of this whole project. But what they didn't realize, and what they're extremely grateful for now, is that all the things that we did to make it a zero energy project really is helping them with resilience on so many levels, right? So they've got these batteries that help them through a number of outages and ice storms in the last couple of years. The insulation in that wall and the roof is really buffering them from the extreme weather events. Many schools have had to close during these really hot heat waves. They stayed open every day, and not to the parents' dismay, right? It's more comfortable at school for their kiddos than at home. The ventilation system that we can dive into in more detail if you guys want to has really helped with COVID. The parents, the teachers, the kids all just feel so much safer with 100% fresh outdoor air. And then they can turn off the ventilation from the outside when there is a wildfire event that has a lot of smoke in the air. And you know, they've been there for 40 years. They've got these amazing permaculture gardens. They've got rain gardens and water catchment, et cetera. That's all helping them feel more secure for a future that may have food insecurity and water scarcity becoming more and more prevalent and kind of at the forefront. So they're feeling like they really made the right choice, and it's paying off in dividends in so many other ways than they expected. We can also talk about financial support a little bit more later if you guys are interested, but basically they got the PV system completely paid for through the three things that you see listed on the slide: a PGE grant, energy trust incentives, which is specific to Oregon, and then parent contributions. They have a big alumni group, me included, that really was excited to support them in this endeavor and be part of the PV, making it happen. At this, we can open it up to a conversation.